Hi guys, I just want to show you an example problem of how to make an energy diagram. I'm gonna go away. I can't when I pull up my sketchbook. You won't be able to see me anymore, but I just wanted to pop in and say hi, and I'm leaving. Goodbye. Okay. So I've got to go to my sketchbook. That's where a sketch pad. That's where our problem is. So in this problem, we want to draw an energy diagram for the following reaction. 2C2H2 plus 5O2 makes 4CO2 plus 2H2O. Okay, and I've already given you some energies, but let's talk about first the steps we want to do. I'm going to write them over here. Steps. The first step I've already done for you, and that is going to be to determine energies for reactants and products. So I did that. Here are your reactants, and when we add them together, this is our energy, 5,085 kilojoules. And then here are our products, 4CO2 plus 2H2O, those are our products, and that has an energy of 8,260 kilojoules. Not all your problems are going to be like this. The first ones you'll see will be, but later on you're going to have to identify, oh, if I'm given the bond energy of C2H2, oh, I don't mean to cross that out, bond energy of C2H2 and O2, I need to make sure to multiply it by this one by 2 and this one by 5, and add them together to get this. So you'll kind of have to do a little bit of like baby algebra to do it. And then for your products, you'll need to go, oh, if I'm given the energy for carbon dioxide, I need to know to multiply it by 4. And if I'm given the energy for water, I need to know to multiply by 2 and add those together to get 8,260 kilojoules, so your total energy of your products. Okay, so that's the first step, but we've already done that. Well, I did that. Second step is going to be to determine delta H, which is your enthalpy of your reaction. We're going to go into lots of detail on how to do the big boy version of this, where you only know the chemical reaction. You're not giving any information about the energies of like C2H2 and O2. You have to go figure it out yourself, and then you'll get delta H. But we're going to do the simple version right now, which is you just need to take your reactants energy and subtract away your product energy. Okay, so we'll do that over here. Reactants minus products. Okay. So that is going to be 5,085 minus 8,260. Got my calculator here, and that is going to be, hold on. Let's see, 5,085 minus 8,260 is going to be negative 2,455 kilojoules. And this is your delta H, or your enthalpy. Great, so we've got an enthalpy. Now our third step is going to say, is this exothermic or endothermic? You got to figure that out. This has a negative delta H value. So negative delta H, that's exothermic. If it had been a positive delta H, it would have been endothermic. Okay, and then your last step is to draw the correct graph. For endothermic, you would need to say, oh, if it's endothermic, I have to absorb some of that energy, and that means my graph's going to look like this. But for exothermic, I know I'm going to have to release some energy, so that means it's going to look like this. Now you're probably thinking, but wait, isn't there more bond energy than before? And the answer is yes. And I really wish I had a good way to reconcile the way the graph is set up and the way we calculated enthalpy, but I do not. It seems like an old dead guy put this graph together, and this is what we do in chemistry, and you know that this is your delta H, and we just have to deal with it, and I'm very sorry about that. But this is the steps. That's why we're only doing qualitative graphs. is because quantitatively these graphs don't make sense. You just happen to know, oh, it's a negative delta H value, so I'm just going to draw it below, and then my delta H is going to be that negative 2455 kilojoules. And that's just going to be what we do. Not the best solution, but it's kind of what we have. Hopefully it sort of makes sense. Y'all go practice, and I'm going to stop recording here. Bye.